The impact of flange finish on gasket performance. Considered an essential component, a flange is a type of mechanical seal that can connect valves, steam traps, strainers, and alike in a piping system. While non-metallic flanges such as glass and reinforced plastic are used for some services, most flanges are metal. Ultimately, in their simplest form, two flanges are joined together and have a gasket placed between them. The importance in choosing the right gasket is vital to an application's reliability and integrity. A critical and fundamental aspect of sealing is the level of friction between the flange and gasket surfaces. The roughness of the flange faces can have a dramatic effect on gasket creep relaxation, blowout resistance, and bolted joint tightness. Depending on the type of gasket used in a connection, different flange surface finishes should be utilized to optimize gasket performance. The four basic finishes for ASME B16.5 and B16.47 flanges are stock finish, spiral serrated finish, concentric serrated finish, and smooth finish. Let's talk about stock finish. This is the standard flange finish and most widely used, unless otherwise specified by the purchaser. The stock flange finish is a continuous groove produced by using a 1/16 inch radius round nose tool with the feed of 1/32 inch per revolution. The spiral serrated finish is also a continuous groove like the standard stock finish in that the groove is generated with the 90-degree angle V tool. The groove is 1/64 inch deep and the feed is 1/32 inch for all sizes. Concentric serrated finish. As the name suggests, this surface finish is made up of concentric grooves. A 90-degree angle V tool is used and the grooves are 1/64 inch deep and 1/32 inch apart. Finally, the smooth finish. This finish shows no visible serrations and is more common for low pressure or large diameter pipelines using spiral wound gaskets. Here are a few guidelines for a safe seal. A minimum seating pressure must be achieved to make the gasket material flow into the flange surface irregularities. When the ridge surfaces of a concentric serrated finish are closer together and the grooves, also referred to as the RA, are shallower, the flange area begins to resemble a smooth face flange, and hence there is more contact area. A spiral serrated finish is more difficult to seal than a concentric serrated finish because the gasket material must reach the bottom of the valley surface to avoid a spiral leak path from one end of the spiral to the outside. Now to summarize, the finish of the gasket seating surface has a definite effect on the ability of the gasket to create a seal. Soft gaskets are designed to have a seating stress that allows it to flow into the serrations and irregularities of the flange face. This bite aids the gasket in resisting the effects of internal pressure, creep, and cold flow. It is important to follow ASME PCC1 guidelines on contact surface finish, surface flatness, and defect depth to exploit the best gasket performance and avoid leaks. It is always best to consult with the gasket manufacturer to determine the best combination of flange surface finish, gasket design, and gasket materials.